Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss reliability and validity of an instrument. Now, if we talk about the measurement scales, we are already having the scales which are related to weight, height, and liquid. We can measure these things very easily. We are having the weighing scales. So, if I want to measure the temperature of a person, I can very well use the thermometer. But if I talk about to measure the temperament of the person, it's not easy. What I'll have to do, I'll have to take some statements which are representing the construct which is a temperament. So after taking the statements, I have to check the reliability and the validity of the statements and how reliable and valid the statements are. Why? Because the basic concept in any research is the concept of repeatability and reproducibility. That if the same survey is repeated, will I be able to reproduce the result or not? Now, this concept, let us try to break it and understand in the same football team. These players are playing for this particular football team, and in the first match, the performance was good. Now, the same players are repeated in the another match after some time. Will they be able to perform well? So, if they are able to perform well, then what we will say that this team is reliable. The same is applicable in our research also, that the statements which we have used to capture loyalty, if the similar survey is carried out by some another person at some another moment of time, will I be able to reproduce the result? If yes, then I will say that my instrument is reliable. Now something more related to that is validity. Validity means that statements 1, 2, 3, 4, this would be closely associated with each other. The definition goes this way that the convergent validity means how closely items of same construct, the items, this construct should remain same, the items are related with each other. Let's take a layman example. That again, this football team which is there, how much cohesiveness is there among the team players, right? If the cohesiveness, we require that the cohesiveness should be high in case of team. If we have achieved this, then we will say that the convergent validity is achieved. Now, talking about divergent validity, say for example that loyalty has got some statements and satisfaction has got some statements. We want high correlation among the statements, among the items here. We want high correlation among the statements in this. But listen to me carefully. We want low correlation between the statements S and T. We require low correlation. So the definition goes this way that a divergent validity means how closely items of different construct are related to each other. We want low correlation among these statements. If we achieve low correlation, then we have achieved the divergent validity. Now, how to evaluate the performance of the team? Say, for example, we are having pool of players who will be representing our football team as we have discussed. We are not going to select all of them. They will be selected on the basis of their past performance. Now, those team players which are not able to perform well, we will not select them in our team. The same is case in our statements also. That those statements which are not going to perform well, they will not be considered here. Now, what do I mean by performance here? How will I capture the performance here? Let us understand. The same statements S1, S2, S3, S4, they are being represented. They are representing a construct which is loyalty. Now, what is the explanatory power of S1 on loyalty? Or rather, I will say how much variance S1 is able to explain on loyalty. That is how much variation S1 can capture of the loyalty. This is known as variance explained by S1. So, what we will get is S1 performance is evaluated on the basis of variance explained. Normally, as we have seen, the performance should be more than 50%. Why we have selected 50%? Because if we go according to the probability, if your statement is not contributing more than 50%, then why we should take such statement? Because nature's probability is 50%. So at least you should go above 50%. then only we will say that this statement is having the explanation power. Now, what is a path coefficient which will be generated in your smart PLS? It is a square root of 50%. So the figure turns out to be 0.708. So outer loading which will be generated in smart PLS, it will be based on path coefficient. Now we will be having the variance of statement 1, variance of statement 2, variance of statement 3, variance of statement 4. When we will do the summation of this, we will get total, and when we will take the average, we will get average variance extracted. Again, this should be more than 50%. Why? Because overall, how the team is performing will be based on AVE, because now we are considering the variance of all of them. So this is the way to ensure the reliability. Now there are some statistics which we will use. One of them is indicator reliability, which is item loading. Here it should be more than 0.708. We have already discussed this thing. Why? Because square root of 50% is 0.708, and therefore we want that the path coefficient should be more than 0.708. There are some other statistics which are being generated, that is composite reliability and Cronbach alpha. It should be more than zero point 0.7. Rho should be more than 0.7. That's basically related to the internal consistency reliability. These threshold limits have been specified in the book. That is a primer on partial least square, which has been published by the developers of this software. That's a Professor Sarstedt, Professor Ringel, who has published this book. Convergent validity should be more than, that is AVE should be more than 0.5 if you want to achieve convergent validity. Divergent validity is rather we are trying to discriminate. We are using two statistics, that is one is a fornell-larcker criteria, that is a diagonal elements which we have to consider, and another is a heterotrait-monotrait ratio, HTMT. Now, how we are doing this in Smart PLS, let us go there. I have already explained to you how to draw the diagram in my previous videos. Now, how to carry out the analysis of reliability and validity, we will see. Okay, so you will have to go and calculate PLS algorithm. Now, the statistics which are related to the measurement model, outer model. When I talk about outer model, I am talking about the relationship of the blue with yellow. Okay, that is a measurement model. So all those statistics which are related to the outer model are in PLS algorithm. So when I click on it, I will get three weighing scheme: centroid, factor, and path. Most of the times we rely on the path scheme because our objective function is to maximize R square. That is, R square is the overall explanatory power of the model which we want to maximize, and therefore we will run it. Start calculation. First we will go in outer loading. Remember one more thing, outer loading is used when your constructs are reflective. Outer weight is used when your constructs are formative. What is a reflective and what is a formative construct, we will see in our subsequent sessions. Now, first of all, we have to see this OC1. It is red. It means that if you take the square of this 0.670, it is not going to go above 0.5, which means that this OC1 is not having a good explanatory power on the organizational commitment, or rather this statement is not contributing in the performance of the construct, which is organizational commitment, or in other words, this team player is not at all contributing in the football team. Now what to do? Should I delete it or not? Now, the authors have got some, you can say, they have defined some method when to delete the statement. First, we will go in the diagram and we will see where we are having low outer loading. So you can see OC1 is having low outer loading. You should not delete the statement directly, but you should follow the path which has been specified by the authors. So the path is that first of all check the outer loading, which we have already checked. It is red. We will see about this branch first. If your outer loading is green, And if AV, CR, Cronbach alpha and rho, they are also green, it means that the validity is achieved. From where I can get these statistics? They are generated here only. In PLS algorithm, you will have to click on construct reliability and validity. They are all green. They are all green. Now, our is a second case, which means that this one. Here, the outer loading is red of OC1, but the AVE, CR, Cronbach alpha and rho are green, and therefore we will not delete the variable. We will keep the variable as it is. So this variable is not harming us. No need to worry. But if this AVR, CR, Cronbach alpha and rho, if they were red, then we will have to initiate some actions. We will have to delete this. Now, how to delete this? Let's understand. There is one default data set which has been given in SmartPLS, that is ECA in ECS. Run ECS in default colors and you will come to know that loyalty is represented by three statements: Kusal 1, 2 and 3. Image is represented by 5 statements, expectations by 3 statements. Now I'll run the PLS algorithm. So calculate PLS algorithm. We have already discussed. We'll have to activate the path coefficient, start calculations. First of all, go in outer loading, and you can see the range of statements which are underperforming, like Q6, Q6 3, Kusal 2, image 2, image 3. Now, when it comes of deleting the variable, there is some method which you will have to remember, and they have suggested that delete the variable first with the lowest loading. Delete the variable with the lowest loading. What the path is? Outer loading is red. AVRCR, Cronbach alpha, rho are also red. Let me check that also. Are they red? Construct reliability and validity. Yes, they are also red. Now, in this scenario, uh, if I talk about outer loading, Kusel is loaded on loyalty and Q6 is loaded on expectations. Are they red? Yes, they are red. And now it is a time to delete the statement. So first of all, we will always delete that statement which is which has least explanatory power, or we will delete the spots person who is less contributing in the team. And you can see Kusal 2. It's not at all contributing, 0.20. And therefore, what we will do, we will again go in the diagram and we, sorry, not this diagram, this is, yeah, Kusal 2. We will delete it. And then we will again run PLS algorithm. But this time when I run PLS algorithm, make sure that my Kusel reliability scores should turn green. If they don't turn green, then there is some issue which we will discuss later on. But after deleting, if they turn green, then Kusel 2 has to be removed from our analysis. Calculate PLS algorithm, start calculation. I will again go in outer loading. Kusal 2 is no longer the part of the system. Everything has turned green. Fine. Go in construct reliability and validity. So loyalty has turned green. It means that Kusal 2, the underperforming statement, has been removed and we have achieved the construct reliability and validity. But after deleting the statement, at any moment of time, they remain red only, then what to do? So let us go there again in the flow. What the flow is? Outer loading red, AVSCR, Cronbach alpha, rho red, deleting the variable with lowest loading one by one. They have turned green, which we have seen in our case that the loyalty construct have turned green. It means that this Kusal 2 has been removed from our analysis. But after deleting this variable, still AVCR alpha and rho are red, then there is a serious problem in the data, or there is some unengaged respondent, or there is a problem of outlier. Now, what do I mean by this and how to resolve such problem? Let's see the remedial measures which can be carried out if your this thing turns out to be red. What are the remedial measures? So the first thing which is there is that you will have to see, is there any unengaged respondent or not. Unengaged means that there may be some participant in your survey. See, these are statement S1, S2, S3, S4, and S5. And these are respondent 1, 2, and 3. Now, this particular respondent, he or she is not reading the questionnaire and he is doing the extreme ticks 5, 5, 5, 5. Now, what will happen is that this particular person, which is there, if you compute the standard deviation of this, standard deviation from here to here, you will get the standard deviation as 0. Now, such scenario is not at all appreciated in analysis. So you'll have to find out the unengaged respondent in your data and you will have to solve the problem. This is one problem. The second type of problem can be that there must be some statements which are highly correlated with each other, like statement S2 and S4. Now, if this scenario is there, S2 and S4 are highly correlated with each other, then in such circumstances also the reliability and there will be lapses in the reliability and the validity, which we will have to understand. The third type of problem can be the problem of the outlier, that someone has ticked the data entered is 10. It cannot happen, but say for example there is an out extreme observation that 10 is there, outlier is there. So in such scenario also your results can deviate and you will not be able to achieve reliability and validity of an instrument. So this is establishing the reliability. Now how to check the validity? So for this purpose, again we will go in our model and we will click on discriminant validity here. Okay, at any moment of time in construct reliability and validity only, at any moment of time, you forget the threshold limit, no need to worry. Just click on the graphs which are being generated. They are having a blue line, which is the threshold limit of Cronbach alpha, rho, composite reliability, and AVA. You can also copy this chart from here, copy to clipboard the chart, and directly you can copy it. Okay. Now, how to check the validity? That is discriminant validity. Basically, discriminant validity is that we want low. The statements of one construct should be not correlated with the statements of another construct. This we can do from here, discriminant validity. The criterion which is used is fornell-larcker criterion. Now, how we have to interpret this? So, for this purpose, I will take one screenshot, and I'll take this in Word file. Now, we will interpret this as, in case of fornell-larcker criterion, it is necessary that diagonally our diagonally now how to understand this? In case of fornell-larcker criterion, it is necessary that diagonally this value should be maximum. It means that, say for example, I am taking one value which is 0.836 for the environmental perception. This value should be maximum in corresponding column and it should be maximum in corresponding row. If we achieve this, then we will say that we have achieved the discriminant validity. These figures which are there, apart from diagonal figures which are there, they are all correlations. These are correlations. This one, they are correlations. Now, it was found that there is some biasness in fornell-larcker criterion for assessing the discriminant validity, and the new statistics was developed by Professor Hensler, Professor Ringel, and Sarstedt, and they came out with the concept of heterotrait-monotrait ratio of correlation, a very novel approach which was developed in 2015, very recently. So HTMT is a measure of similarity between latent variable. If HTMT is smaller than 1, discriminant validity can be regarded as established. In many practical situations, now what is the threshold limit which has been specified? The threshold limit specified is 0.85. If we get HTMT less than 0.85, we can say that the discriminant validity has been achieved. So for this purpose, we will have to go in SmartPLS click on discriminant validity, and click on HTMT. Now all of them are green. It means that nothing to worry. Things are working perfectly because all of them are less than 0.85. At any moment of time, if you forget the threshold limit, you can again click here and you will be able to see uh, if they are all green, no matter, nothing to worry. Now we will see the case study which was being generated, ECS, that is a PLS algorithm, and let us try to evaluate the discriminant validity of this. So here also, fornell-larcker criterion, you have to see diagonally, this is there. Heterotrait-monotrait ratio, now there is a dispute. You can see that the values have crossed, that is more than 0.85. Now, what does it mean? The quality and image, they are having 0.983, satisfaction and image 0.91. So it is very well possible that the statements of quality which are there are related or having a correlation with the statements of image. This can very well happen when respondents are filling up the questionnaire. They are getting confused, or rather they are getting confused between the construct quality and image, and they feel that this more or less they both are same construct and they are giving same rating. And what will happen is that we will see high correlation among quality and image, and when it happens, our divergent validity is lost. The only thing which we can do is the refinement of the questionnaire. Where we are having overlapping, we will have to find out, or rather we will run the correlation among the items, and wherever the items, that is the statements of quality, are highly correlated with the image, those statements are to be refined. So that is all about reliability and validity testing in SmartPLS. So thank you to all of you. You can subscribe to my channel and you can follow me on LinkedIn and Twitter. Thank you.